Hello, test. Hello everyone, my name is Nils. Today I'm going to talk about troubleshooting Split 7.2 using srsRAN. And first up, how do I, no, how do I, yes, okay. First, a little bit about myself. So I did my degree in Germany in the Ruhr University in Bochum and got hired by SRS right after. In the first year, I was working as a software engineer, mainly working on the CI/CD. After that, I transitioned to system administration and DevOps. And yeah, mainly still looking into the CI/CD, but also managing our on-prem and cloud infrastructure. I got tasked with real-time tuning for our testbed, and I took care of the Kubernetes clusters that we have. And for the last year and a half, I was working in customer integrations. So basically working with our clients, helping them to deploy their networks, maintaining deployments, and supporting our customers. So before I want to jump into the debugging process, I want to show you guys the tools that I'm using to debug my deployments. Yeah, one of the first tools that I use is the help function of the CUND or the G0B application. Very helpful. For example, if you transition to a new release, maybe the config has changed. So yeah, something to look into to debug your config and your parameters. We also have a config validator that will tell you if you configured something wrong. So read what the G0B console tells you and you're gonna be good to go. Yeah, the next tool that I use is usually the console, the output of the G0B, for example. And yeah, it gives me kind of an indicator if the network is running as I want it to, or if there are potential issues. It's really hard to tell from just this what is going wrong, but it gives you an indicator of yeah, if the network is performing well or not. Yeah, so the next and most important thing are the logs. So you will see all of the issues, all of the errors and warnings in there. You can enable them per log, per layer base, same as the PCAPs as well. And you have 3 different log levels: info, warning, and debug. For debugging, it might be, you might think, okay, maybe I start with debug. I would not recommend this because you have hundreds of megabytes of logs. So go first with warning, and later on, if you want to debug something very specific, use the debug log level. And one trick that I want to show you here is recording PCAPs. So you can record PCAPs inside the G0B, but this does not cover the whole messages. So what I think people usually do is just using TCP dump, but if you use DPDK, this is not possible. So what I do there is I use port mirroring on a switch. I just send all of the traffic coming in and out of that port to another one and record it there just without DPDK. In case you don't have a switch and you need to record PCAPs directly on the DPDK interface, you can use DPDK dump PCAP, but it's very difficult to set this up. So if you have a switch, try this first. Okay, then the metrics, also a very good, like a good source of information. They can be printed into the log as well as you can get them from a TCP socket. They can be enabled per layer basis as well, as you can see here in the config snippet. And if you get them on a TCP socket, you can pass them yourself, or you can use our Grafana dashboards. They are available via Docker Compose and Helm to set it up easily. And these are some of our dashboards, so you can get lots of metrics out of there, visualize it in a nice way. Maybe not the best tool for debugging issues, but if you want to have like a good overview of your network in a deployment, this is definitely something that I recommend to use. Okay, and then something that is, in my opinion, a really great tool for debugging is the test mode in our G0B application. What it does is it basically enables the whole stack by emulating UEs being connected to the RU. And this helps, especially in the first stage of an integration, helps a lot because you can see if your system is actually capable of running your configuration. So you just set up your configuration, you enable test mode, and with this configuration, the system will run basically. And if you have a look at the logs, you will see issues or not. So it's a good indicator before trying to attach a UE, for example. We support downlink indicator in the downlink rank indicator 4 and in the uplink rank indicator 1. And then something else that I also think is very useful is cyclic test. So cyclic test is a tool that measures the wake-up time of threads on a given CPU. And this tells us how fast the CPU reacts, basically. So what is the latency of the CPU? And since our application is real-time critical, we want the latency to be as low as possible. And so the setup that I'm usually using here is I first run srsRAN, which is a tool that basically stresses the CPU. And then I run this with real-time priority as well. And then I run cyclic tests. You use for both srsRAN and for cyclic test the same, so the number of threads is equal to the number of cores. And as well, don't run it for like 10 minutes. There could be events coming up like every hour or every 2 hours. And so what I recommend is to run it over at least 24 hours. You should, if your system is configured properly, you should see something sub 25 microseconds. You can get it very low if you really know what you're doing. So I've seen systems around having a response time of like 7 or sub 7 microseconds. If the latency is too high that you're encountering there, usually this comes down to the system configuration. So review the kernel arguments that you set up. Make sure that the real-time kernel is installed and the settings of it are set correctly, and the CPU isolation that you're applying is also correct. And then the last tool you might know already is HTOP. It's a nice tool, should be coming in almost all of the Linux distributions. If not, you can simply install it. It helps me to see if there is something wrong on the system. Is maybe something running really high in CPU usage? Is there maybe something else running in my isolated cores? So it gives a good overview of the system. It's important that you show the custom thread names, which is not enabled by default. Otherwise, you don't know which thread is running high in CPU. I also like to show the kernel threads, which helps to see if, like, for example, an IRQ is running high, or if there are any issues like this. And I also like to add the processor column, which shows which thread is running on which CPU core. So then before debugging deployment, or before like setting it up, I strongly recommend to plan your deployment. A lot of people have issues deploying like our software, or in general like a complete run, because they just jump into it and then they get stuck at a certain point. So you can save yourself a lot of time by planning before getting into it. And from my personal recommendations are to use, for example, if you go with AVX 512, use, if you go with x86, use AVX instructions. We also perform good on ARM, so this is also something that you could use. If you haven't bought hardware yet, go with the single NUMA CPU and also single socket. It's really hard sometimes to set up like these big epic CPUs. They are nice if you want to run many cells, but if you have the option, integrate something with a single NUMA, single socket first, because it's much easier, and then transition to bigger CPUs. And don't use big little architecture CPUs, because we've just seen they just don't work well. Yeah, so software recommendations. The first and I think most important recommendation I have is use the docs. We have everything documented, so every single step is there. Plan it well, like set up the real-time kernel, set up DPDK. Don't start with the regular interface. There are so many things that can go wrong. DPDK is maybe a little bit of a hassle to set up, but as I said, we have a tutorial for this. And use TuneD for your system configurations. If you're experienced, maybe this is not necessary, but TuneD is a tool that brings all of the system configuration together in one config file. And this helps a lot over time, because you can keep track of what actually happened there. Configuration-wise, yeah, go with the default or the example configs that we have, preferably like 20 megahertz to don't stress the CPU too much. Make sure you've updated drivers, firmwares, and the BIOS as well. Also tune the BIOS for performance, like these bigger servers like Dell, Supermicro, and all of the like proper server vendors. They offer like performance profiles for the BIOS. And yeah, also something important, use Git for your config files. If your integration takes a little bit longer, it's beneficial that you can go back and check, what did I do yesterday? What did I do last week? Yeah, you're gonna forget for sure if you don't use it. So then the debugging process. I want to show you how I do it. You can do it differently, but I think like I have my own method, and this is separated in 3 steps. So the first step after planning the deployment is hardware verification using test mode. So we run test mode to see if the application runs well. Once we are sure about that, we attach a UE to see if COTS UEs can attach to our network and stay attached, do what we want. And then after that, I usually optimize the RAN parameters for performance. So, okay. Yeah, the first step would be, does the GNODB start or not? If it's not starting, you can use the help function. Maybe the config validator is complaining about something. And something that I've seen a lot is this DPDK error, device not bound to DPDK driver. This can be due to different things. So could be that IOMMU is not enabled. It could be that srIOV is not working properly. Firmware of the NIC could be a problem, or something that this error doesn't really tell is that the L cores are not available to the GNODB. So be careful if you do CPU isolation. If you do this, make sure the DU has access to the cores that you define in the L core section. It could also be that the CU cannot connect to the core due to wrong configuration, TAC, PLMN, or the slice configuration. Yeah, then once the GNODB is started, as I said before, I have a look at the console. So just to see how is it performing, is there something obviously wrong or not. With like a little bit of experience, you know more or less what is happening, but don't bother too much with it in the beginning. Just go to the log file in case you see, okay, it's not clean. Maybe we have retransmissions, stuff like this. So it's a good indicator in the first place to see if the network is performing properly. Yeah, then we look at the connection between DU and RU. So once the network is up, test mode is running, maybe it shows me a little bit of errors. I first go to the KPIs of the RU and the DU to see packets arriving in time. Like one of the most common errors is, for example, that VLAN and MAC config in the DU or RU are wrong, so packets are not arriving on one of the two sides. It could be that the switch is configured badly and drops packets. It could also be if you don't use DPDK, maybe the interface is not up or the MTU settings are not correct. That's why I'm saying use DPDK from the beginning. It makes things easier. Or in some situations, it could also be that your switches are just overloaded. Yeah, and a good test is to ping the RU from the DU or vice versa. If packets are arriving but they are not in time, it could be that the PTP infrastructure is not working well. So if you use a switch, make sure that the switch is performing correctly, sending PTP. Yeah, if this is the case, it can also be that there is a problem on the DU server itself. So usually what I see is that NTP is enabled and is messing with the system clock, which leads to spikes in the PHC to sys, which then leads to late and early packets in the DU and RU. And something else, so some RUs have very specific timing windows. This is also something to consider here. Review the documentation of the RU and eventually adjust those parameters. Usually you don't have to. All of the RUs that we've integrated with have default parameters in our config files, so you find everything there. If you're integrating a new RU, make sure that this matches. Something else, yeah, is the drivers of the NIC and firmware. They can cause a lot of problems. Make also sure that you've updated all of the drivers. So I spoke to someone recently who had problems with virtual functions and they updated the regular driver and the firmware, but they didn't update the virtual function driver. So make sure you have all of the drivers up to date. And if all of this is done and you still see problems, maybe it's the SFP link. So cables, adapters, or what I've also seen once is like a client used a switch which was not PTP compatible. So this is also necessary. Make sure that the network elements support what you need. All right, so we assume that the traffic is arriving in time. We have a connection between DU and RU, but we still see problems in the log file. So we could see messages saying woke up late, downlink queue is full, timeout reached, real-time failure. This usually comes down to either performance issues. So make sure that the srsRAN performance script is running. It could be that like some buffers are not adjusted correctly. So if you use 100 megahertz, UDP and TCP buffers have to be adjusted. At least under Ubuntu, I don't think that this is going to work well if you not do it. Yeah, you can check HTOP, for example, to see what is going on my CPU. Is there anything hitting a limit, anything on 100%? Yeah, and also double check your TUND system configuration. Then you could maybe also see packets like missed sending in slot, missed slot, or received a packet in wrong slot. This is usually due to the configuration between DU and RU. So make sure that the PREG configuration is correct. The header compression is something people sometimes get wrong. Yeah, PREG CP enabled, disabled is something that I see a lot wrongly configured. And yeah, the antenna configuration as well as the TDD or FDD configuration. So once you receive packets in time, make sure, and you still see errors, make sure that the config that you have in the DU matches the RU and vice versa. Yeah, then also something that could happen is that the RU receives traffic but doesn't send anything. This could be due to the IQ scaling. So if we tell the RU to send higher power than it actually supports, it could be that the power amplifiers are locking up. And yeah, the RU basically just doesn't send anything. So make sure in the logs of the RU that it's operating properly. And if you have the possibility, use a spectrum analyzer. If you start with 20 megahertz, you should be able to use a simple USRP like a Blade RF, Pluto, B200, something like this, in order to just create a simple spectrum analyzer to see what is the output power and yeah, is it actually sending something on the correct frequency? Okay, so now we are at the point, test mode is running. We don't see any issues in the log file anymore. And yeah, the next step is now to attach a UE to confirm that the COTS UE stays attached to the network. If you've done your job well, you've planned your network well, you've done the test mode step correct, at that point, you should be able to attach right away. But sometimes you miss something, happens a lot. So if the UE stays attached for like 10 minutes and is able to ping the core, you can usually assume that your configuration is correct. But it could be that the UE is not seeing the network but cannot attach. Oh no, sorry. The UE is attached but doesn't have an IP address or don't have connection to the internet. This usually comes down to the APN settings. So this is something between UE and the core. Make sure that this is set up correctly. It could also be that the forwarding settings in the core network are not set up. So you basically get an IP, but you cannot access anything outside of the network. Open5GS, for example, has a tutorial on this, how they propose to do this with their stack. And it could also be that the core network, that you attach to the core network, but something is going wrong in there. So make sure once you attach the UE that the core network is running properly as well. And yeah, it could be that the UE attaches but detaches like after 60 seconds, for example. And this is usually because the UE searches for an IMS in your setup, doesn't find one, and then detaches. So if you don't have an IMS in your setup, disable this also on the UE side. It can be a little bit tricky, but if you Google, you should find something there. So then the cases that happen more often. The UE can see the cell, the network, but it cannot attach. So this can be due to wrong SIM credentials. You would see something like this directly in the log of the core network. But it could also be that the SUPI encryption is enabled. And this is something that you have to fix on the SIM card. So yeah, make sure that the services that are enabled on the SIM are also available in your core network. And sometimes I've seen this as well when the PREG config is not correct, and then the UE can see the cell, but it cannot attach. So also if the core is configured correctly, make sure that yeah, the G-Node-B config matches the RU config. Yeah, then could also be, I hear this a lot, UE can't see the cell. So the easiest fix is sometimes the frequencies set incorrectly, the center frequency and the ARFCON, so make sure this matches. Sometimes the TDD configuration is not set up correctly, can also lead to the same behavior. For errors, check the metrics, the OFH and RU metrics. Maybe something went wrong in the last 10 minutes after you did the test mode check and some traffic is not arriving in time. So make sure you monitor this constantly. And yeah, use a spectrum analyzer to ensure that the RU is actually radiating on the correct frequency. IQ scaling could be a problem. as I said before. And sometimes it's an issue of the UE. So some UEs don't like radio link failures and just blacklist PLMNs and frequencies if they have failed to attach. And then there is a timer in the UE, and you can reset this by ejecting the SIM card and putting it back in. Airplane mode or restart does not reset all of them. So ejecting the SIM card should help here. Yeah, then something else is like if you, for example, integrate N48, make sure that your UE can actually attach to those bands. And sometimes there are vendor locks. So we've seen this 2 years ago on our first workshop. We had a setup that worked perfectly fine in our lab in Barcelona. We came here and the UEs were not attaching anymore. It was a specific vendor. I don't want to talk too much about this, but yeah, maybe try a couple of different phones to make sure that it's not the UE that is like having or making problems here. Yes, so yes, now to the last bit. So in this section, we already have checked the test mode, we have attached the UE, but maybe the throughput is not what we want to have. So in this section, I want to show you my strategy of optimizing the RAN parameters a little bit. The general idea is to attach a COTS UE to the network, push maximum traffic using iPerf, and then observe the network parameters. And yeah, and then we can trace potential issues individually because well, I explain this in a second. And yeah, the setup, usually what I do is I set up the UE 3 to 5 meters away from the base station, no line of sight blockers, and very important, make sure you don't have interference. We had this once with a customer who was testing a certain frequency. They wanted to deploy it in a client's infrastructure where they have the license for the spectrum. But in the test lab where we integrated our software, there was actually interference, and it was impossible to optimize the RAN parameters in this scenario. So make sure you don't have interference while doing this step. Yeah, so what I usually do is like first a ping test, if you haven't done this, just to see without a lot of traffic, is there connectivity? After that, I go into UDP and I test it individually, downlink, uplink, and then bidirectional traffic. And after that, I go into TCP. And the general approach is like I make sure the network is up and healthy. I attach the UE, I push traffic, and I observe those RAN parameters. And yeah, if I find a problem, I adjust the config and I go again until this certain step works and performs well. So what do we want to observe? What are we doing when we are looking at this? So one scenario could be that we have low retransmissions, which are called NOC in our GNB console, low OC, which are like the transmitted packets. This would mean that there is like a low throughput, for example. This could be due to due to buffer sizes, either TCP or UDP. As I said before, they need to be adjusted if you use high bandwidth deployments like 100 megahertz, for example, will need adjustments. It could be performance issues. So have a look at the log file, for example, if you see any issues that we've already discussed in the earlier steps. And yeah, make sure that the backhaul interface is also working properly. So make sure that, like, for example, the MTU is set up correctly. If you have high CQI, push SNR, or like a high knock rate and low MCS, usually, or like a situation that could happen is that the scheduler is adjusting or is reducing the MCS because of a high blare. And yeah, this again can be due to performance issues, for example. So if you have this scenario, you see like high blare, make sure that, yeah, the CPU is performing correctly. Power calibration could be an issue. So maybe some of the values like the P0 nominal or the SSB block power are not set correctly. Or it could be that there is interference. Yeah. Then could be that like the PHR, the power headroom that the UE reports is low. So this is usually also due to the power calibration. So something is not correctly set for the path loss calculation of the UE. Or it could be that there is like a low push SNR and low RSRP. This usually also tells me the power with the G0B sense width is not too high. So power calibration is one thing to look into, and interference. You might ask yourself now, okay, how do I tune those UDP and TCP buffers? How do I find issues there? Or what can I do about what does power calibration mean? I'm at the end of my talk, so I don't have enough time to go into this. But for the power calibration, there is a really nice presentation from Joachim, my colleague, from last year. You find it on YouTube. And for the TCP stuff, my colleague Pedro will today have a whole presentation about this. So if you're interested in debugging these issues, go there. The UDP is usually easier to debug. So if you adjust the buffer sizes as we describe in our documentation, you should be good to go. Yes, all right. I'm at the end of my presentation. Thank you for your attention. And yeah, in case you have any questions, I'm all ears.
Yeah. Okay. So you mentioned that ejecting the SIM tray could reset a blacklist timer in the event of something like a radio link failure. Is there any way you know of to disable blacklisting, or not really?
No, I think this is not really exposed because it's happening in the baseband, and if you use a COTS UE, you don't have access to the baseband. So I'm not aware of anything. What you could do is use a modem, like a Quectel modem or Telit, or and these things don't have the OS layer on top, and they usually don't do this. So yeah, this would be a cross-check if you want to say it like this. Yeah.
Quick clarification. You mentioned a few times about using real-time kernel.
Yeah.
Does it mean the low latency kernel, or?
No, the real-time kernel. So the low latency and the real-time kernel, as far as I know, they are a little bit different. And the real-time kernel has these preemption with the real-time priorities. And this is what we are using in our application. So if you want, well, it's basically necessary. Maybe if you're lucky, you can use a generic kernel for like 5 or 10 megahertz. Could be enough. But I strongly recommend to set it up. And usually all of the bigger vendors like Ubuntu, for example, ships it in the Ubuntu Pro subscription for free. Rocky Linux, you can just install it. So yeah, should be.
It's basically a different kernel than the generic and the low latency, and then
Yes.
real time. Okay.
Yes, exactly. Yeah.
Are you running the cyclic test on just the physical cores or all hyperthreaded cores? And then if it's, I guess, regardless, how do you actually read that graph to make changes to your EAL configs?
We just go back here. You mean this graph, right? So usually I don't have the graph. Usually I have the console output of the CPU. It's very hard here to tell which CPU it does problems because yeah, but it gives a good graphical representation where you can see, okay, is there something wrong or not? What I recommend is just use the command line tool. it will print values for all of the CPUs, and there you have all of the information you need. And where do I run it? So usually I isolate CPU cores, physical and hyperthreading, and I run it on all of them. And you use one thread per core, not physical core. So if you have hyperthreading, you use twice the amount of the physical cores that you have.
So I guess if you had plotted it like you did with this graph, how do you actually like look at this and determine whether or not to use a core?
Yeah, so as I said, like the graph here is more for the presentation. It was something to just visualize how this could look like. It's possible to generate this with cyclic test as well. So, but if you have the console output from cyclic test, you will see per CPU latency, max latency, and you have all of these values per CPU. And if you see that, like, for example, the average or the max latency of a specific core is very high, from that you can tell, okay, maybe there's something wrong with this core and I shouldn't use it in my deployment, for example.
Are you considering very high, anything above 25 microseconds?
Yeah, it depends a little bit on the CPU. So it's could be 30 is also still okay, but everything above usually tells me there is something wrong. And I look into it again and yeah, try to fix it. You're welcome. Yeah.
Thank you for presentation. I'm Yoshi from SoftBank. Thank you for presentation again. And then my question would be, the engineer always suffer from segmentation fault. Then I just wonder if segmentation fault occurs, the software will generate core dump, right? Then
Yeah.
That's my question.
The core dump will be generated, yes.
GDB debugging.
Ah, okay. You mean the debug trace. So what you have to do there is you have to build the G0B in debug modes in order to, if there's a seg fault, which I hope doesn't happen, then you have like the whole output if you build in debug modes. So if you look into the CMake file, you will find the release and debug. And if you build it like this, then you will have the GDB trace in the console.
Thank you.
Yeah,
One
you're-
question would be
yeah.
the interface between CDU and RU. So normally, currently we are using
Could you?
ECPRI is very popular between interface between DU and RU.
Mhm.
So question is ECPRI supported in the software? Because ECPRI is important to analyze frontal lock
Yeah.
based on PCAP.
Maybe I forward this to Andre as well.
Yeah, I can take that. So this talk and in general O-RAN like has adopted open frontal, so the O-RAN open frontal interface for connection between RU and DU. So it's eCPRI, while it's the basis for open frontal, it basically provides the framing sitting on top of Ethernet, and then it's following the O-RAN specification. But this is what we are being discussing here, and that's used, yes. So you can collect PCAPs and analyze them, and with Wireshark, for example, and it's following the O-RAN frontal specification. But it's not using proprietary, so there are eCPRI flavors with proprietary fields and vendor-specific things that we are not supporting. We don't. I mean, that is the main advantage of adopting O-RAN in the first place. For frontal DU, RU connection.
I mean, basically this software is based on the O-RAN specification, and then
That's right. Yeah.
what we could be decided by the users. Like the user can select EC3, other user can select another interface, right? That's cheap.
Yes, so what we are supporting is O-RAN frontal 7.2 A and Split 8 currently. Split 8 is a version where you send IQ baseband over the link to the radio, to a software-defined radio, for example. But yes, I mean, we have integrated this software in our open frontal implementation, which is, by the way, some other DUs use srsRAN or Intel FlexRAN inspired one, and this is a implementation from scratch. So we have implemented and integrated it with a large variety of IU vendors. So commercial IU vendors that are deployed in public networks, as well as testing equipment. So it's standard compliant and has been validated with like dozens of IUs, from various vendors.
Okay, okay. And then final question would be, what do you recommended memory size?
Memory size
Yes.
depends a little bit on the deployment. So if you want to use 20 megahertz, you don't need as much as 100 megahertz, and also depends a little bit on the amount of users that you're using, because for every user you need more RAM. So I think 4 gigabytes per G0B. Or
Per cell, I mean, that's
per cell, yeah.
So no, it would be below a gigabyte, so 800 megabytes per cell, more or less. But again, yeah, depending on the number of users that you're attaching, and in the buffer status, and in the number of retransmissions, and queue size that they occupy, this may grow. But basically, the baseline is like 800, 850 with L1 and 2 L3 for a single cell.
Okay. How many UEs can be connected to this system?
In general,
In
so
general,
there's no
maximum UE.
there's no hard limitations. So we have tested with the measurement equipment that we have at hand up to 1,000 UEs in RC connected mode. So that is 1,000 UEs doing traffic at the same time, so not idling. So and this is supported on a single cell. So a little bit more than you typically have for private 5G networks.
Yeah, please.
What procedures or tools would you use if you were trying to go about debugging something like poor time sync with PTP, or like incrementally falling out of sync under a heavy throughput load?
Yeah, so usually first I would have a look at the PTP Grandmaster itself. So is it doing what it's supposed to do? Is there maybe, if you use an external one, could be that it's maybe, yeah, how do I say, it's not running well. And in terms of tools, I would have a look at the logs of my, yeah, usually I use Linux PTP. So I would have a look at the PHC to sys logs, for example, and compare over time, are there any spikes? Is there anything out of the ordinary? If that's the case, look into the kernel logs with dmessage, for example. Yeah, what else? It's hard to tell. Like looking at the NIC, maybe there's something overloaded. Could be a real-time problem as well. So HTOP, and then checking what is going on. Is there maybe a thread running really high in CPU usage? Yeah, so debugging PTP is usually a difficult thing if it's not the PTP Grandmaster.
Would you recommend running your PTP or PHC or both with different CPU priority tags, or like tagging it as a real-time thread or anything like that? Or
yeah, that's a good question. So I think the real-time priority doesn't really make a difference there. But what you could use, or what you could do, is if the system is under very high load, you can put it on an extra CPU core to make sure that it has enough resources to run and does not get interrupted by the G0B, for example. Yeah, this is what I can say. Yeah.
So like a core that you haven't assigned to the G0B itself.
Yeah, or maybe you have it assigned already, but you have to take it away for debugging, and then yeah.
Thank you.
Yeah, you're welcome. All right, I think we're at the end. If you have any more questions, you can just catch me here on the hallway. And yeah, thanks for your attention, and